Today's topic is rotate an array. So this is an given array and the k value will be given, which is the rotation of array, which in this case is 1. We will rotate an array for one position. The output will be 2 3 4 5 1. So first we will see the naive approach. So this is the code for reversing an array, which I explained in the previous video. So we will be using this. So what we will be doing is a k value will be given. So we will first give a for loop, and we will call this method reverse. Means for given number of time, that if it is 4, we will call the reverse as 4 times. So this will work for this will work until we give a value which is lesser than the length of the array. Here you can see the example. So when the k value is 0, it will be same. When k value is 1, so you can see here it shifted from one position, like that 2 3 4 5. You can see here when it is k value is equals to 5, this, and when the k value is equal to 0, this, and when k equal to 5, these both arrays are the means output are same. So like that you can see here when k value is equal to 2 and k value is equals to 7, we can see here the output of these two are same. So there might be some relation, that is nothing but k mod length of the array. You can see here k mod length of the array. Like in this case we have taken the example as 5, which is the length of the array. For k value, like here is 7, to get the same output as 2, what we'll do is k mod length of the array, which is 5, k 7 mod 5, which will will get as 2. The output will be 2, and what we will do is we will first take a mod of the k, means we will take first we will take the value of that, and we will rotate an array till the k times. You will call that till so here is 7. To get the same value, same output as 2, what we will do is we will apply this, means k, which will be the given number of position we have to shift, like 7 mod length of the array will give us the value which will be lesser than the length of the array. So here you can see the output will be same, means the output will be lesser than the length of the array. And what if the k value is negative? So if it is negative, you can observe that the negative value in this case is -1. Means if we do a -1, it will rotate clockwise, means the last element will come at the first index. If it is -2, means 4 will be come here and 5 will come here, like that. So here we can see that when it is a minus value, like -1, in this example we can see that when k and -1 value output are same. So there we can conclude that when k equal to 4 and when k equal to -1, we can see that the output of these two are same. So that is when we get the negative value, we have to just add k plus length of the array, will give us the value what we required here. Means you can see that when we get a minus value, in this case it is -1, that the output will be same when it is equals to 4. So what we will do is we'll add -1 plus 5, which will be equals to 4. So this is the program. This is nothing but the reverse, means rotate by 1. It is equal to that, it is same as reversing the array. So what we'll do here is we'll take the array and the length of the means number of times you have to rotate the array. So first we will check the array index, sorry, this is the rotation, number of times we have to rotate. K value, k mod length of the array will be give us the number of rotations we have to do. So we are checking here. If it is a negative value, we will add here with the length of the array. So now we have to call this rotate one. So here we are calling it till k times I is less than or equal to k. So we will rotate an array one by one, means till for k times, then we will get the output. Time complexity of this program is k times n. So rotate 1, which is this function, here it will call till the length of the array, so n, and this rotate function we are calling it k times here in the rotate method. So it is k into n, big of k into n. So now we will see the efficient approach. Here the given value is k and this is the array. So this is nothing but there are three simple steps here. First we will partition the array into two parts, which is 0 to k minus 1 and k to length of array minus 1. So what we'll do is we will call the reverse function 3 times totally. So we will call the reverse function for the first partition array, which is from 0 to k minus 1 and k to length of array minus 1. After this the output will be like this, and next step what we will do is we will reverse the entire array and we will get the output. So here we are calling 3 times the reversing of the array. So now we will see the program here. This is nothing but the swapping, which is a reversing function there. And here we are calling the rotate function. Here we are checking the k value, and if it is less than 0, we are adding to the length of the array. And here you can see, here we are calling the 3 times. First one is from 0 to k minus 1 and k to length of array minus 1, and again rotating the whole array will give us the reverse index, will give us the, so we'll give the rotated array. Now we will see the time complexity of the program. So here reverse function is called 3 times. Here we can see, here we are calling it 3 times. For first time from 0 to k minus 1, and second time from k to length of the array minus 1, and third time the whole time. So we can say that we are calling it as 3 times and 3 times, so that we are traversing it till the length of the array, means here we are traversing till k minus 1, but we will still consider it as n. So after ignoring the constants, we will get big O of n. Thanks for watching this.